Good morning, everyone. Our team is Bombardiere, and we comprise of Joshua, Brian, Adriel, Junxian, and I myself, Marcus Ho. So, to give you more background info about Bombardiere, Bombardiere is a multiplayer action-based game, and it is hugely inspired from the running series called Bomberman. The general goal of Bombardiere is to strategically place bombs in order to collect the most points from picking up power-ups. The last man standing score will be recorded in the leaderboard. Moving on to unique features about the game, our game has customizable maps, where users can customize and render their own map by editing a CSV file. We also make use of retro graphics to give a player a sense of nostalgia. Lastly, we have audio customization, where users can change the background music by changing the WAV file. Moving on, I'll be passing my time on to Adriel.
So this picture shows the full UML diagram for the game. We'll be going through in detail in the following slides. So starting from the leaderboard, it has a composite relation with the score and the UI. Then the game panel also has a composite relationship between UI and the game screen. And it also implements the runnable interface and extends to the JPanel class. Then from game screen, it extends to the JFrame class and has a relation with the sound because the sound is loaded by the game screen and the game screen uses the sound. So the game object manager, the tile manager, and the sprite loader are all called by the game panel to load the different sprites, the tiles, and the objects of the game. Starting from power up, bomb, heart, explosion, all of these classes extends into the game object manager as they are part of the game objects in the game. The explosion class and the bomber class implement the collision interface, and then the key handler is binded to the bomber so that the bomber can move using the arrow keys. Key handler also implements the key listener interface. I'll now pass on my time to Brian, who will be explaining more about the encapsulation used in the program.
Thank you, Adriel. Here we have one of the example of power-up encapsulation class. The getter and setter for power-up class does not show any of our main function regarding the power-up. And the information will be hidden so that other programmer will have to use either getter and setter to read or set data, so that it will be easier for them to understand and the code won't be as messy as it is. Other programmer won't be able to mess up the overall code structure as well. Now we'll talk more about encapsulation in the next slide. Here we have two examples, attribute, getter and setter. In the attribute part, the bomber class has all the attributes set as private. So for example, private player ammo, private max bomb, etc. This means that the attributes are only accessible in this current class. In a getter and setter example, once player 1 is being bombed by the other player, and if his current state is not invincible, the player 1 will take damage and player 2 will increase the score by 5. As you can see here, player 1 function will -1 and player 2 will get score. One of the example for polymorphism is overloading. So we can have multiple methods with the same name, but just that the parameter will be different. The first part will be fire power out. When a player firepower is maxed out, it will not increase the player firepower and it will return 6. As 6 is the max value, it will not go more than that. The next fire power out is the second function, and there is both x and y parameter. So when a player get power out, it will increase power out by 1 as shown in the parameter y. Then the second function will be the bomb timer. The first method will be the set maximum timer to 300, and the second overloading method will be the x and y for bomb timer. So every time when a player get a power up for the bomb timer, it will decrease the bomb timer to -15. And the last method will be the max bomb. It's similar to firepower, just that the first one will set the player max bomb to 6, and the last method will be the one with two parameter x and y. And every time the player get power up, it will increase the bomb by 1. And now I would like to pass my time to Joshua.
Thank you, Brian. Hi, I'm Joshua. I'll be presenting more about abstract classes in our game. So one of the abstract classes is a game object manager, which has a abstract method draw, which will be used by all of the other child classes of the game object manager. An example of inheritance is the bomb class, which extends the game object manager, and some of the other examples of inheritance is in the explosion class, the bomb class, and the power up class. Now I'll be talking about the interface, which will be used to specify a specific behavior of the class. We created a collision interface which will detect the collision of the entity and a tile, explosion and a soft wall, bomb and the bomber, and whether the bomber has picked up the power up. So some of the other examples of the interfaces that we use are runnable interface, key listener, and collision. For the error handling portion, we have a few try and catch blocks throughout our whole code. This helps us to maintain the normal and desired flow of the program whenever unexpected events occur, so it will not break our code. So now I'll be showing you guys how to download the file from our GitHub repository. So first of all, we'll go to our GitHub repository, and under code, you'll hit download zip and wait for the file to finish downloading. After the file has finished downloading, you can unzip the file, and inside there will be a .jar file which you can run, and the game will be launched. Now I'll pass my time over to Junxian, who will be explaining to us about the game mechanics.
Thank you, Joshua. Firstly, we shall look at the leaderboard. On startup, the game checks for a save file in the form of a comma separated values file. If the file does not exist, the game creates a save file. However, if a save file is found, the time, names, and scores are read and placed into a linked list of objects, with every set of time, names, and scores as an individual object. When a game ends, the times, names, and scores are returned to the save file and the linked list. Error handling is implemented on opening, reading, and writing to the save file to ensure that an error in the leaderboard does not affect the other functionality of the game. Currently, the leaderboard shows the scores of the games played recently. Next, we shall look at the help menu. The help menu shows the controls for the players of the game. We shall start a new game. On starting a new game, a random map is loaded. Currently, we have 4 maps in 4 comma separated values files. In the game, there are collision checks. Objects such as bombs and walls are impassable. There are also objects that can be destroyed, such as soft walls by bomb and power-ups on collision. When a player is hit by a bomb, a collision check occurs and he is put into an invulnerable state for 6 seconds. Whenever a player picks up a power-up, he gains 3 points. And whenever a player hits his opponent with a bomb, he gains 5 points. If a player bombs himself, he gets 5 points deducted from his score. When a player's health drops to 0, either from being killed by the opponent or by bombing himself, the game ends. When the game ends, the game asks for the name of the winner and the score is recorded in the leaderboard. Now, as we can see, the leaderboard has been updated with the latest scores. That is all for our presentation. Thank you for watching and have a good day.